Rat Kitty Cats, continuing our hormone discussion. In the last video, we looked at aldosterone. Previous one before that, we looked at ACTH. So ACTH is a trophic hormone, causes the production and secretion of other hormones, and in this case specifically, ACTH being released from the anterior pituitary gland, targets the adrenal cortex to produce and secrete aldosterone and cortisol. So we talked about aldosterone, and let's look at cortisol. So cortisol is obviously secreted by the adrenal cortex when the anterior pituitary gland releases ACTH. Boom, we got that. So cortisol is also known as the stress hormone. So it's cortisol is released from the secreted from the adrenal cortex when the body's under stress, whether physical stress or mental stress. Either way, our bodies will increase that cortisol secretion when there's stress in the body. So cortisol is, just a note, is a steroid, so it's nonpolar, which means it doesn't dissolve easily in the bloodstream. So guess what? You need a carrier molecule, a transport molecule to transport the cortisol throughout the body. Since it is nonpolar and cannot dissolve, it is not soluble in blood because blood is mostly water, and nonpolar and water just doesn't work out. Water is a great solvent, but only with polar and charged molecules. Since steroid and cortisol is nonpolar, it won't dissolve in blood, won't dissolve in the water. But with the cortisol targets, the target organs or target cells is cortisol targets the liver to increase glycogenolysis, increase gluconeogenesis, and decrease glycogenesis. So what cortisol does is pretty much dumps nutrients, dumps everything from our stores of energy into the bloodstream to increase our energy levels to be able to react to the stress. So targets the liver. Cortisol being secreted or released targets the liver to increase glycogenolysis, the breakdown of glycogen into many glucose, increases gluconeogenesis, so the production of new glucose from non-carbs such as lipids and amino acids. And then obviously, since there's an increase in glycogenesis, since there's an increase in glycogenolysis, there's going to be a decrease in glycogenesis. So once again, it's pretty much decreasing the storage of glucose in our body. Also, cortisol being secreted from the adrenal cortex targets adipose connective tissue. So what the targets whenever the cortisol being secreted by the adrenal cortex targets adipose connective tissue to increase lipolysis and decrease lipogenesis. So increased lipolysis, kind of similar to glycogenolysis, just obviously with adipose. So increase in lipolysis means the triglycerides are being broken down into fatty acids and glycerol. They're kind of more available source of energy. So increased lipolysis, triglycerides are breaking down to glycerol and fatty acid, ready to be used for energy to respond to the stressor. And there's also the cortisol targets the adipose connective tissue to decrease lipogenesis. So lipogenesis is the opposite of lipolysis. So it decreases fatty acids and glycerols combining together to form into triglycerides. So all of the energy stores are being pretty much broken down. So glycogen's being broken down into glucose within the liver, and then within the adipose, triglycerides are being broken down into fatty acids and glycerol molecules. Also, the cortisol, the release of secretion of cortisol from the adrenal cortex, which is caused by the release of ACTH from the anterior pituitary gland, targets many cells. So it breaks down protein, cortisol does. It aids in breaking down protein, which leads to many amino acids there. So it breaks down protein into many amino acids, pretty much just breaking everything down. And also, by targeting many cells, it decreases the cellular uptake of glucose, cortisol does. So there's going to be more glucose in the blood, less in the cells, decreases the cellular uptake of glucose. So in other words, cortisol inhibits or blocks insulin secretion. So as we know, insulin causes blood glucose to decrease. It increases the cellular uptake of glucose. cortisol kind of blocks this off because cortisol decreases the cellular uptake of glucose. So it says, okay, nah, the glucose is staying in the bloodstream for that immediate energy. So cortisol pretty much dumps all of the nutrients into the blood to react to the stressor. So under physical or mental stress, cortisol is going to dump all of our energy stores really into the blood to really, so we have energy, so we can produce ATP. Really, that's the whole name of the game. Dumps all the nutrients from our storage, whether it's glycogen, protein, triglycerides. Dumps it all into the bloodstream so we can produce ATP to react to these different stressors. So when stress levels increase, you're also going to increase water reabsorption, which increases blood pressure. So when we're stressed, can increase our blood pressure will increase, which can affect the heart negatively, especially if high blood pressure for too long, too much stress for too long. It'll negatively affect the heart. Also, when stress levels are increased, inflammation is going to decrease. So inflammation is good. It's a good defense mechanism. It's in moderation, but if you decrease inflammation too much, it's going to also cause the immune system to be suppressed. So when we have a suppressed immune system, guess what? We increase the risk of our infections. So stress levels increase water reabsorption, which increases blood pressure. So when somebody's stressed, blood pressure is going to skyrocket. Also, increased stress levels decreases inflammation, and decrease inflammation too much, that's going to suppress the immune system, which will increase the risk of infection. Not a good freaking scenario. So the stimulus of cortisol obviously is due to the ACTH secretion from the anterior pituitary gland, but essentially increased stress and ACTH secretion are the stimuli for cortisol secretion. The cortisol, aka the stress hormone. Once again, cortisol is secreted by the adrenal cortex due to the release of ACTH from the anterior pituitary gland. So just some side facts here, some side notes about cortisol, just diving a little bit deeper, a little bit more below the surface. Cortisol actually inhibits ACTH release. So this is a negative feedback system. Cortisol blocks or inhibits the ACTH release. So ACTH release causes cortisol to be secreted by the adrenal cortex. So the cortisol blocks this ACTH release, which is to regulate the levels of cortisol, which is pretty cool stuff. So hypothalamus, last but not least, releases corticotropin releasing hormone. So as we'll discuss in one of the next couple episodes here, hypothalamus, it not only produces certain types of hormones to be released by the secreted by the posterior pituitary gland, also acts as a releasing and inhibiting hormone, which regulates the production and secretion of anterior pituitary gland hormones. So in this case, the hypothalamus releases corticotropin releasing hormone, which causes ACTH secretion from the anterior pituitary gland. So this corticotropic hormone that the hypothalamus releases, corticotropin releasing hormone, causes the ACTH to be secreted by the anterior pituitary gland, which ultimately targets the adrenal cortex for the production and secretion of cortisol and aldosterone. So it's pretty honestly freaking awesome how all these parts of the hypothalamus, pituitary gland, all the hormones work together, and we really don't even have to do anything. We just sit back, relax, try to stay balanced, and our bodies is going to try to help us keep balance, keep the homeostasis. Homeostasis is the name of the game, but cortisol, stress hormone, keep your stress down, keep your cortisol secretion down, but if somehow stress goes up, ACTH is going to be released from the anterior pituitary gland, cause the adrenal cortex to increase the production and secretion of aldosterone and cortisol.